This Pyrometer, figured we'd play around with a little bit and take a look at it. I used it in the soldering iron video. I borrowed this. Has a nice case, no holes. When I first got this, I looked at it. I was wondering where the plug is or where the batteries are, but apparently there is none, because it works without it. So, and I just recently started really digging into this thermocouples and all this kind of stuff, and learning a little bit about it, and never had no reason before to even deal with any of it, I guess. But yeah, we seen this work in the soldering iron video, but I just thought we'd just play around with it a little bit and pop it open and see what's on the other side of it. So I just got just a couple small pieces here, two different kinds of thermocouple wire. And when I didn't know what thermocouples were actually made of, I always thought the little ball on the little end was some kind of magic sensor or something like that. I never knew that it was just welded together, fused together. So, you know, you live and learn, I guess. So if we put this in here, the red goes on the negative, and that goes there. Well, let me start out here by saying that it has this little information in the top, and I'll put that up so you can read it, you know, if you want to. But this here explains, this is the instructions for a Model B pyrometer. A Model B pyrometer. Pyrometers are calibrated for a specific thermocouple resistance and thermocouple type. This unit is calibrated for thermocouple type I and C, which is iron and Constantin, I think it is. Thermocouple resistance of this thermocouple is 1.75 ohms, but that's not the type that I have here. This one that I just put in here is a K. The K, which is chromium and aluminum, and this one here, it has I don't know if you could see the colors or not. It's red and it's blue. And that is a T, which is a copper and Constantin. So, oh, and another type I got here was, you're familiar with this from the other video. This one here, I did some studying up on it and looking into it, and don't mind these two on this end. This is the heater. But these two here go to the thermocouple in this, and this is a type J in here, I guess, which is just, they're black and white, but it's a coating on there. But they're from what I've looked up, it's just bare wires. But it's almost the same as these, though. It's really, I guess the J and the K are close. I was just playing around with this, and the red wire on here is magnetic and the other one's not. And the red wire is the nickel plated aluminal. I don't know why I can't say that word. And this is the same thing. It doesn't stick to this here, but it does to this, to the black. I don't know if I can get that to show me that or not. Let's see if we can move it. No. Oh, there, the white. The white is the one that is magnetic. Without even touching it, I can move it. So I'm thinking this, you know, this is the same type of material as the other one there. But that was just something I was playing around with. And this one here, this T-type here, neither one of these, you know, of course copper isn't, but this silver one isn't either. That's constant 10. I guess that's not magnetic. Now, and this one here, this is the same. This is the K one. This just has that spade connector on the end. The spade connector itself, I don't believe is magnetic, but once you get it closer up to where the wire is, then it is, because the red one is magnetic. And you can get these spades made out of the specific material, the chromal and aluminum. You can get them made out of copper, and you can get them made out of constant tin. So you can buy these off the internet, so this way you don't have to fuse the wires together. You can just put them in there and crimp them together, and there's your thermocouple. Which makes it easy if you ain't got a spot welder or something like that, which most of us don't. So I'm just going to stick this in here. I can find a hole there. I have this set to my house temperature, because if you read in the instructions or directions or what about, however you want to put it, API Instrument Company put that in there. That's who makes this, I guess, out of what is it, Chesterland, Ohio. So put those in there. This is the negative side. I have this set to room temperature. It tells you that you should have this set in whatever room it's going to be in for an hour, so it does whatever it needs to do. But if it doesn't go to the room temperature, you can tweak this little screw right here to set that needle to whatever your room temperature is. And mine is about 64 last time I looked. Yeah, something about 64. So I just put it in between 60 and 70 there. Each long line is 50. Here, let's make this interesting and connect the meter too. What do we got here? Red there. Put that on millivolts. Now the nifty thing about this is all you have to do is touch these together, and you can see the needle rise. You can see it move just a little bit. Can you see me? I'm just squeezing those together, and you can see it's moving. Now it's up to about 70, 75, something like that. Breathe on my fingers a little bit, see if I can move it up. No. Last time I played around with this, I was able to get it up to about what our body temperature is. I don't know why I can't now. But, and of course we got no reading over here. Now, one thing, well, let's do this first. So the easiest way to make a thermocouple is just take the two separate wires and twist them together. That's the easiest way. Like I said, in case you don't have a spot welder or anything. which I don't, but I'm thinking in the near future here I'm going to work on a project that will do little tiny spot welding things, kind of about what you've seen on the internet, I'm sure, but I want to try to just fiddle around with my own. So let's twist it together now. So that's pretty much considered a thermocouple. And I have this hooked up properly because when I put my finger on here, this needle goes this way. If I swap these wires around, the needle's going to go the other way. I got a lighter. Let's just watch it. You can see I have it connected the right way because it's going up. And my meter is connected wrong because it's a negative number. So I'm just going to swap those so my red actually goes to the positive on here, and my black is going to go to the negative on here. So now my meter should read the right way, and that's in millivolts. Now this lighter is only going to get so hot, so that temperature is only going to go so far. So those of you who like to do math and all that kind of stuff, you can figure out the actual temperature by doing the, see, that's 200, let's see, 250, 220, that was 220 that we had it going up to. And you can actually do the, oh, now it's past it, do the math to get the real temperature reading, but I'm not gonna, I'm not a math whiz, so I'm not gonna do that. But you have the millivolts there, 12.4, and you have 250, 60, 70 degrees C. So if you got 270 degrees C, let's say 260 degrees C, well, if the needle will stay still, of course I'm moving my hand, so it's wherever the thermocouple is in the flame, it's going to either get hotter or colder, so you're just trying to hold it really still. So let's say 260 at 12.9, let's say, millivolts. So if you get the NIST chart and you do all the math and calculate it from absolute 0 C, then you'll know, you'll get the actual temperature, because you know the ice water thing and all that. I don't get into it that far. I'm not a circuit designer, so I'm not worried about that. So that's how that works. Now you've seen the meter go backwards. This is what'll happen when we do this backwards on accident. And I know you're guessing it right now, and you're right. I won't connect the meter up this time. But now if you watch the needle and we heat this up, now you can see it's going backwards. So you have to make sure you hook your thermocouple up the right way. Now there is one thing I was going to kind of go over what we found in this here, and I can't remember if I went over it in that video or not, but we'll just cover it here real quick. Right here, what we found in this is, I don't even know if I have to heat this up or not. See, our reading goes up real nice and everything, but if we actually disconnect one of these and pretend it's a failed thermocouple, I mean, mean, I don't even think it matters if I heat this up. It's reading because I still have the meter connected. Of course, this is not reading, but this one was actually going all over the place because it was failing. Disconnected on here. I don't remember which one was which. And you can see the numbers just jumping all over the place. That's how you can tell if you got a bad thermocouple, if the number is jumping all over the place like that. So it really doesn't matter. I could take one of these off and that number is still going to jump all over the place. So that's kind of what that's kind of gives you a clue right there. If everything is working properly, when you connect up a good thermocouple to your meter set in millivolts and nothing's going on with the thermocouple, that's the way it should read. It shouldn't be jumping all over the place or anything. It should be just waiting for some temperature change. I'm not warm enough to change the meter. So if it's jumping all over, you probably have an open thermocouple. And I believe, slide this over here just a bit, and I believe I did this. I know I just put the video out there, but my memory is short. I'm going to connect this to one side of this thermocouple. And I'm going to put my meter on the beep. So it beeps if we short it out. Now I'm going to put it on here. So that's one side of the thermocouple. Here's the other side of the thermocouple. So that tells us that that side of the thermocouple is shorted out to here. And that the thermocouple is broke, because this side should beep too if this thermocouple was still together, welded together, and was touching the case. So another test you can do to see if you got a bad thermocouple. Now there's sand in here. I was gonna look it up, but I can't remember what type of sand was in here. But if you shake it, you can hear sand. And I don't know if I'm shaking it, if it's moving that thermocouple wire. Maybe it's moving it away from the body. Let's connect it back up. Nope, still shorted on the black, not on the white. Let's see if I can connect it and then shake it. Must be pretty stiff wire in there. Yeah. Stops once in a while, but I don't know if that's me probably. But yeah, so that's just another way you can test and show you that the thermocouple is bad. Alright, enough of the playing around. Let's see what's in this thing. We'll tear it apart a little bit just to be nosy. It's not mine, so I have to be careful and not take it too far. Not enough to where I can't get it back together or something goes wrong, or I just have this stuff there to help prop it up a little bit. Break out our, to make it a little bit quicker, we have 4 screws in the corner. is a nice case that they put it in. Can't beat the case. I mean, this, like I said, I don't know how old this is. If anybody has any information on how old this particular one is, that'd be interesting. Like I said, it's a Model B pyrometer. There's really nothing else I can tell you about it. Now, before we get any further tearing this apart, I did read something on here. If no thermocouple is supplied, or if a different thermocouple is used, the calibrating resistor bobbin mounted beneath the panel must be trimmed so that the total resistance of the thermocouple and the bobbin add up to the calibrated thermocouple resistance given on the pyrometer dial. I'll show you a blown up of this a little bit, but right down here it says 10 ohms. So I'm assuming that's what that's talking about right there. So that our thermocouple wire and the bobbin that's in here, we'll find that out as soon as we open this up. I guess both of those together, when this is connected here, it has to equal 10 ohms. That's the way I take it. And if it doesn't, then we need to adjust the bobbin somehow. So I want to make sure I got that in there. Alright. And it also says when you transport this thing around that you should leave a thermocouple connected or jump a wire across there. I guess that helps for the needle, because that needle, you can see, moves real easy. So you don't want that thing bouncing all around. Ta! Nothing. I thought maybe there was going to be batteries in here or something. But this is just a gauge. I have seen one of these gauges on the internet. I can't remember what somebody wanted for it, what the price was, but like I said, there's hardly nothing at all on the internet about this. So this must be the bobbin here. So this bobbin and the thermocouple is supposed to equal up to 10 ohms. Well, I think the only way you can change this from the looks of it is you have to desolder it from either that terminal there or that terminal here, and cut the wire off or put a longer wire on there. More resistance for a longer wire, less resistance, shorter wire. That might be a pain in the butt to do, I don't know. And I'm thinking that's probably special wire, it's just not regular wire. Let's see what that measures right now. We'll put our meter on, get that out of the way. Sorry for the light glare there. I'm going to get this light situation figured out sooner or later. So I'm going to touch the meter on. Got to fix that sometime. Okay, so I'm going to touch the top and the bottom, and let's see what it reads. Make sure I get a good connection. Reads 8.1 ohms. So we would have to change that, and 8.1 ohms. Our thermocouple, let's put that right down here. We'll measure, how about we do it right over here. Make it closer to the meter. Get down there. Our thermocouple reads 4.4, so we got 12.5, something like that, resistance, so we're off a little bit. So we would have to adjust this by a couple ohms. Is it really worth it? I mean, I guess it depends on what you're measuring. But for this process, what we was doing here with the soldering iron, I wouldn't even worry about it at all. Nothing has to be that perfect when you're just soldering something. Alright. I mean, I'm sure we all know what's inside meters, but if you want to stick around, we can take a small peek at a little bit. Like I said, this is not mine, so we'll be real careful about how we take this apart. So let's see, we got some wrenches here. Let's see, 3/8 maybe. Yep, 3/8. Another 3/8. Let's see. We gotta get these out of the way first. Us electronics guys always gotta see what's going on the inside of things. Just a clamp. That's a good way to do that. Let's see, what do we got here? The meter that I saw online, that was just like this, it didn't have a bobbin with it, so I don't know if these bobbins come with all of them, or if it was taken off of the one that's online, or not sure. That's there. I'll take some pictures of this stuff and pop them around up here so you can get a little bit closer look at this stuff. I'll take some pictures after we get it all tore apart, and then when I edit the video all up, I'll throw the pictures in. Let's see, okay, we gotta get, what is this? Oh, look at that, 5/16. Having one of those little wrench kits works out. All different sizes. They come in handy, and they're thinner too, so that helps on a lot of this kind of stuff, especially this. I wouldn't be able to get a regular one in there. Glad I had those around. I don't know why they have this little plastic piece. They're not separating anything from each other, because the threaded rod here does touch this. So I mean, I don't know if it's just to act as a lock washer type thing. Once you squeeze it down a little bit, it holds it. Alright, let's see. Alright, there's that. Set that off to the side. This, I guess the model number of this thing is a 603. I don't know what all these other numbers are, but it says mod right there, so I'm assuming that's the model number. Mod ND, right? Makes sense to me. What do we need? Where's my screwdriver? Here's my screwdriver. don't tell the person who I borrowed this from that I took it apart. This is our secret. Something just pinged. I don't know if you heard it. Oh, I see our little, can you see that little thing right down there? That's the adjustment thing. Oh, there, it just jumped back. That's what moves when we adjust the needle. I guess I'll make that straight up and down because we're going to take it straight off. Maybe that'll be the best place for it. Yeah, it's got the two clips right there, so I'm out of it now. I just got to be able to take this off without hitting that needle. Got to be a better way to do it, more carefully. Just like that. I can get this out of the way. I just have that, this is a TV right here, I just had that leaning up against the screen of the TV because I didn't want to ruin the screen. Oh, so that's the little thing there that moves. Probably can't see that the greatest, but it's got a little tip sticking out of it. And then it goes right down in here. So when we move that, it moves this, which moves the needle. Precise adjustment. We can see we got red wire here. Let's you can see how easy that needle moves. Look at that. That's how sensitive that thing is. Just the wind from my hand. Let's I don't think I want to touch these because those are probably where the wires are going to from in here. Let's see what's underneath here. We got 2 screws. Maybe this will show us a little bit of something. I guess I gotta slide it up. Make sure I don't catch that needle. Oh, look at that. I don't know what that is. Oh, that must be holding on the shiny strip. The tape is holding on the mirror, reflecting mirror in there. Alright. Not much in there. We got, let's see, let me get this thing over here. We got the red wire. Looks like it goes down in there. And then it goes right here. And then it's connected to, looks like I'm guessing a thermistor. And I'll put, like I said, I'll put pictures up here so you can get the close-up looks when I go to edit the whole thing. I see deep down in there, looks like a resistor. I see, depends on what glasses I'm wearing. I only can see, oh there it is. It's a 30 ohm at 1%. 30 ohm resistor at 1%, and that looks like it's going to this one here, and this one was the one with the bobbin on it that had our bobbin connected to it. So the resistor's coming off there, and it's attached to the thermistor, and then on the other side of the thermistor you can see the red wire comes up and goes up through here and up to this connection right here. Oh, and that wire moves when I adjust this too. So now the black wire, which of course probably has to be connected to that one, I can't see where that goes, but I have to assume that it connects to the bottom of this point right here. There's the top of the windings that's in there, so the black has to connect to the other side. Otherwise, how else would it work, right? Let's see what we got there. There's a, now I don't know what, I think this is the magnet, because it doesn't really stick to this, but the closer I get to that, that's the magnet there. That's just blowing on it, lightly blowing on it. So that's a real sensitive piece of equipment there. Huh. Yeah, I'll get some close-up shots of that and just have them popping up around here just so you can kind of get a better look. I don't know what this thing on top here is. The red wire goes to that. There's a piece, it's something soldered on there, so, and then it's crimped over the edges there, it's holding that, so yeah. If you make these things, you probably know exactly how all these things work, but I don't make them, so I have to look at it and see what see how it's made. I don't know what the numbers on the side here. I got a 021977 dash, I don't know, 04. That probably doesn't mean nothing to anybody. Got a another number there. Don't know what that is. That's Throton marker, so it's halfway worn off. 8766, but I can't read the first number. Alright, well, I guess that's all there is to this. Something interesting to tear apart. I guess now we know how it works, or how they put it together. Alright, I guess that's it for this one. And we'll see you in the next one.